Hey, physicists, what's the crack? So today we're going to do is waves. Okay, so it says we've got a single slit and we're illuminating it with monochromatic light. Just remember, monochromatic, mono means we're using a single wavelength. Okay, so it says what we're going to do then is we're going to make the slit width is increased. So we're going to make the slit width bigger and want to see what happens to the pattern on the screen. Okay, just a bit of revision. When we've got a single slit, what actually happens is the central point, which is equal distance from the two ends of the slit, is going to be your central maximum, your bright spot. Okay, and the width of that is always 2 times the width of the other fringes. So your central maximum, and then remember the intensity drops further away from the middle. So then the width of these are all the exact same, but the central maximum, the width is always double the rest of them. Okay, so what this equation here is to find out what that W is, and then remember the central maximum is double that distance. So what we've done here is we're increasing the slit width. So S, our slit width, is being increased. And that equation is on your data sheet. If I increase S, I keep the wavelength the same and the distance between the screen and the slits the same. And I figure out what happens to W. So if we increase this number, we divide by a bigger number, W will get smaller. Okay? So I'm going to write that down. W is going to get smaller. So what that means is all of the W's are going to decrease. So my pattern is going to get shifted in together. Because maybe before this was 5 centimeters, but if W gets decreased, it's now going to become 1 centimeter. So it all gets shifted closer together. Okay. The other thing says was what happens with the brightness. Okay. So brightness, we're thinking about intensity. Okay. So I know that what happens here is that the light is diffracting as it passes through the single slit. I know diffraction happens with waves when the gap is either equal in size or less than the wavelength, okay? And that's when I can get the most diffraction to occur. So let's say the gap was super large, we're not really going to get any diffraction, right? But if the gap was really small, I'm going to get loads of diffraction, loads of bending of those waves, okay? So what we've done here, we've made the gap bigger. So what happens is we're getting less diffraction. So I'm getting less diffraction, I'm getting less spreading out of the waves. They're not spreading out as much, they're not diffracting as much, which means more of the light is going to hit the maximum. So because more of the light hits the maximum, that's why it's going to get brighter. Okay, so just to recap, if we increase the slit width, if I make S bigger, I've made W smaller, so the fringes are much closer together. And then because I've made the slit wider, I'm going to get less diffraction. So because I get less diffraction, less spreading out of the energy, that means I'm going to get more concentrated on the middle. So my central maximum will actually be brighter. Okay. So that's grand. So follow me for more physics content like this. And oops, just spelling R.